Hey developers, welcome to MEG Studio, and in this video we will discuss test-driven development, which is an evolutionary approach to development. It combines test-first development, where you write to test before you write just enough production code to fulfill that test, and refactoring. Part of the value of the TDD process is that the specification for the code must be known before work on that code is started. Once the test is written, a cycle is entered into to create production-ready code that follows the process flow in the following diagram. We start with the red phase, in which we write a failing test, and then we write the necessary code to pass this test, which is the green phase, and then we refactor to optimize the code. Note that the TDD process does not stop you refactoring code and maximizing the efficiency of code that will go into production. It also does not preclude the usual code review process, even though arguably you are reviewing your own code as you go. What is the primary goal of TDD? One view is the goal of TDD is specification and not validation. In other words, it's one way to think through your requirements or design before you write your functional code. Another view is that TDD is a programming technique. The goal of TDD is to write clean code that works. I think that there's merit in both arguments. The Agile movement has continued to progress over the past 15 years, leading to new and more pragmatic practices aimed at providing the client with the program that meets his needs as quickly as possible. For this problem, traditional methods based on the V model offer a test-last approach with unit tests written after the application code. This approach has clearly shown its limitations over time, since at best written tests are adapted to the code and not the other way around, thereby introducing a confirmation bias. In the worst case, these tests are not even written since the code seems to work correctly. Why waste time writing them? The answer to this question is obvious to TDD supporters, who are well aware that the investment made today on tests will be largely refunded in the future when adding new features or refactoring operations. Thus, the TDD adopts a test-first approach in which unit tests are written before code, the only reason for which will be the successful execution of these tests. The latter adds to the test-first approach the notion of continuous refactoring with a view to improving product code. Testing and refactoring are baked into the process, which by definition encourages rigor in the production of quality code. Unit testing itself encourages modularity in a code base, and TDD helps with producing well-tested code and has a high percentage of test coverage. The TDD process should save time in maintenance, as defects should be easy to find and are found early in the development process. When developers are involved in testing rather than just handing off their work to a testing black box, they are more likely to be engaged in the process and take testing far more seriously than perhaps they otherwise would. Ideally, a whole company organization needs to support the implementation of TDD in order for it to succeed. Writing tests before writing code means that we need to know the requirements of the software and the specification of the code before starting to code the solution. Is the business set up for TDD? TDD can take longer to code, and some of the advantages are only seen in the maintenance portion of the software development process. Some managers want to see code written now and take the later consequences of poor development processes when and if they come. All code should be modular, which makes it easier to implement testable code. However, we have all worked on software projects that are not well implemented for one reason or another, and we may need to join a particular project that has been through some shaky development practices as it nears completion. We might be led to ask ourselves, how can we easily implement TDD in a non-modular code base? Developing skills around stubbing and mocking can take time, and is this something that the team is aware of and prepared for? Which brings us to an important point. Is everyone in the organization on board? Are there developers who think they write perfect code who refuse to implement the TDD process? How can staff be engaged and encouraged to point in some direction in order to produce great work? So to conclude, the advantages and disadvantages of TDD actually look fairly balanced. You see, the balance is in the quality of the software and the team investing in this early in development of software rather than leaving maintenance to the end of a rather long cycle. If you can develop TDD within an organization, if you have a staff that are capable, this is not to say that it's right for every organization. It isn't, but you need to make your own choices with the knowledge of your organization and programming context. I hope you enjoyed this video. Hit the bell for more interesting contents, and thanks for watching.